Intellectual speed dating. Never tried it before. I want to talk to you about complex and complicated things. And I want to talk about self-healing. I think this difference between complex and complicated is really important. World climate, world economy, practically everything alive is complex. All machines are complicated. But it's difficult to tell the difference between these two systems. Nobody's been able to define it. What I'm going to suggest to you is the big difference between them is that complex systems can heal themselves, but complicated things have to be mended. And I want to explore what the consequence of that is. Let's take a football team, a complex system, and the referee sends one of the players off. You still have a football team. What happens is all the players start to play differently. They relate to each other differently. But the thing that remains is the football team. The football team has healed itself. Same thing happens in a bacterium. Take out a major membrane protein, all the rest of the molecules move around, and what remains is a functional cell. You take a front wheel off a car, I assure you that does not happen. You take a front wheel off a car, you've got a not car. Complex systems, therefore, change everything in order not to change at all. Right? And it's like, yeah, okay. This is one of the most amazing ideas I've ever come across. I owe it to Stuart Kauffman. But that in complex systems, higher level order, the usness of us, emerges spontaneously from the interactions of the other bits. Self-healing involves changing all the bits to maintain this. I was thinking at one point of giving out scalpels and allowing you to cut yourselves. A health and safety problem there. Okay. Some problems. During self-healing, we cannot predict how any of the parts will change. Right? We don't know how they're going to change. We just know that they will to maintain the order. And from that, it follows the reverse, that we do not know how to change the bits in order to solve the system. We don't know how bits are going to change, and we don't know the effect of us trying to change them. And this leaves us with a major problem. We cannot heal complex systems. We may be able to mend cars or moon rockets, but we cannot. They can heal themselves, but we cannot heal them. More importantly, every time we try to heal one, the complex system just sees it as another injury and starts to self-heal from our attempts to heal it. We've got real problems. Remember the kind of complex systems we're talking about, world economies, climate. Now, one more idea to take out of this. Complex systems can self-heal from a huge variety of insults. This is essentially their robustness. Interestingly, we're now learning that they don't self-heal to what they were, but they actually self-heal to what they were going to be. If we'd done the scalpel experiment, you would have actually healed not to what you are now, but what you were going to be in 3 weeks' time when the injury. Equally, self-healing doesn't involve any of the bits knowing that they are bits of a whole. They are not conscious. From all this, I deduce that self-healing cannot be pre-programmed. There cannot be a healing program which tells you exactly how to do it, because there are too many insults and you don't know where you're going anyhow. In complex systems, the elements in the system are not determined. The best way, I think, to describe them is that they react with playful creativity. That's how things work in complex systems. Complex systems, in fact, work because the component parts are locally free. Not like that in a machine, where the component parts are totally determined. There's an automatic consequence of that, is that if you want high-level order in a complex system, you need local anarchy, not top-down micromanagement. These aren't new ideas. Thousands